this transport layer is responsible for process to process delivery. That is entire message. As I said, entire, if I need to send a data to my friend, then that data will be divided into number of packets, right? And these packets are passed over the network, isn't it? So this transport layer is responsible for delivering the complete message to the destination. Okay, that's why it is called as process to process delivery of the entire message, or you can say source to destination delivery of the entire message, right? And a process is what, which is nothing but an application program which is running on a host. And I just listed what are the functions that are implemented at transport layer. The first one is service point addressing. Second one is segmentation and reassembly. Third one is connection control. Fourth one is flow control. And fifth one is error control. So I'll just start with segmentation and reassembly. Okay. So this is the image that we considered in the last class to explain about. One second. Huh. Like to say that the whole process will be delivered from source to destination, the complete process. That means the entire message will be delivered from source to destination. That's why it is called as process to process delivery or source to destination delivery of the entire message. Whereas if you consider the network layer, it performs host to host delivery. That means source to destination, only one particular packet will be delivered from source to destination. The responsibility of network layer is to deliver a packet from the source to destination. Okay. So next, I just started with the segmentation and reassembly, right? See, as you can see in this image, in the picture, there is sender and the receiver, right? The source and the destination. Now, the sender wants to send a message that is, say, that is a long message. Anything you can consider. For example, I've considered this message. So, sender wants to deliver this message to the destination, that is recipient here. Okay, now this long message is divided into number of packets. Okay, this long message is divided into number of packets, as you can see in this image, right? A long message is divided into one packet here. This is a packet, this is a packet, this is a packet. Okay, all together forms this entire message. Okay, so now these packets, so this dividing the what entire message into packets is called as segmentation. Okay, then these packets are transmitted over the network here. One second. Huh. See, this set of packets, whatever created at this layer, that means at the transport layer, is passed over the network and it is delivered again at the transport layer. Okay, and then it will be reassembled. It will be reassembled at the transport layer and it generates the complete message, and the same will be delivered to the recipient. Okay, now the question is, how many packets has to be created for the given message? Okay, so you can't randomly create a number of packets for this message. Okay, so here the criteria that we have to remember is what is the capacity of the link. Say this is the link I'm using to send my message to the destination. That is message that sender wants to deliver message to the destination. Then this is the link using. Then there will certain capacity. Say this link has certain capacity. Okay, say at a given point of time, this link will be able to send 1 MB of data. Okay, consider this is an example I'm considering. Consider this link is able to send at a time only 1 MB of data. Now consider whatever the long message I have created here, that will be of 10 MB of data. Okay, this is 10 MB of data. But the complete message can't be sent over through this link, isn't it? So that's why this long message is divided into number of packets where each packet will be of 1 MB. Why it is 1 MB? Because the capacity of this link is 1 MB. That's why. Okay. So in that case, 10 packets will be created for this data. Okay, and each packet will be sent over the network and it is delivered to the recipient. In the same way, all the packets are sent over this link and delivered at the transport layer. Okay, this we call it as segmentation, and reassembling the packets at the recipient end at the transport layer is called as reassembly. Okay, this is segmentation and reassembly. This function is implemented at transport layer. Is this clear? You understand? Segmentation and reassembly. Students?
Yes, ma'am.
Okay. Next, I'll move on to the next topic, that is service point addressing. Okay, so this service point addressing, it says that addressing, it talks about addressing. Okay, there are three types of addressing followed at the transport layer. One is physical layer, sorry, physical addressing. Second one is logical addressing, and third one is port addressing. Please do remember, service point addressing is of three types. Okay, one is physical addressing. I'll just write it here. Physical addressing, the first type. Second type is logical addressing. Okay, logical addressing. And third type is port addressing. I'll take one by one and I'll explain. Okay, these are the three types of addressing uh, comes under service point addressing. So this physical addressing is MAC address. So physical addressing is also called as MAC address, and this address will be a permanent address. See, if I'm using laptop to take class for you all, so this is a device. Okay, it has its own permanent address. So that we call it as physical address. Okay, so if my device is connected to the internet, then it will be recognized with a permanent address. Okay, so now the question is where I can find this permanent address of my device, right? So that is embossed on your network interface card. So your system, there is a network interface card in the laptop. Okay, on that this physical address will be written, or we can say MAC address. Okay, see, you might have using wireless SVIT wireless network, isn't it? To get register, you might have given your laptop or your cell phone MAC address, isn't it? So that address is called as physical address, or you can see MAC address. And this MAC address is a permanent address of any network device, and each and every device which connected to the internet will have its permanent address. Okay, so now we'll see uh, so let me show you this, so where you could find permanent address. So I just opened this terminal. Okay, uh, where I'll give the command as IP config. Okay, when I press enter, you can see you will get a series of statements here, right? So it will say what are the what IP address and to which you have connected, to which network you have connected. All the details will be given here. Okay, here if you look, you can check the permanent address. Mm, one second. I'll just show you where is the permanent address of your system, or I'll consider this IP config slash all. See, here you can, I hope this is clear. It's visible to everyone. Um, See here, there is a physical address. I hope it is visible to everyone. E0 hyphen CA hyphen 94 hyphen 42 hyphen 5F hyphen 86. So this is the physical address of my laptop. Okay, and one more you can find here, one more address is IPv4. See here, one more address is there, IPv4 address, that is 192.168.1.3. This is the second type of address under service port addressing, that is logical address. Okay, please do remember, physical address is the permanent address of a network device. Okay, and the second type is logical address, right? See, address assigned to any system that is on the internet, so as which is, and this address is assigned in a logical way. Okay, so this IPv4 address is there. No, this is logical address that is assigned to logical way. This address, logical address, helps to identify on which network the system is present. So, see, the address is 192.168.1.3, right? So, this is the logical address that is assigned to my system when it is connected to Hathaway network. Okay. Now, what I'll do, I'll just change my net. Please note down here the IP address of this network is 192.168.1.3. Okay, so now I'll change my network. Okay, so I'll switch on to my mobile network now. So just a minute. So now I connected to Airtel network, which is cellular network of my cell phone. Now I'll check uh, what is the logical address of this this system now. Config slash all. Right? Whereas here you can see the IPv4, that is it. Huh. Here IPv4, now it is different, that is 192.168.43.135. See, previously it was 192.168.1.3, whereas now I connected to a different network where you can see the network. See, is it visible screen, dear students? Is my
No,
screen
ma'am.
visible? 1 second. Okay, now is it visible? Just check.
Yes, ma'am.
Yeah, okay. Now see, you can see the physical address is same as the previous one. Whereas my logical address has been changed here because I connected to a different network. Now it is 192.168.43.135. Previously it was, when I connected to Hathway network, it was 192.168.1.3. Okay, now it has been changed. So that means this address will help you to identify your system has been connected to Airtel network now. Okay, so that is what I just wanted to convey. I'll switch back to the previous connection. Okay. Yeah. Yeah, I hope now it is clear. Under service port addressing, I just explained MAC address, which is physical address, and second type is logical address, and third type is port address. We'll see that now. Yeah. So this diagrams explains the port addressing. Okay. Let me consider this example given here. See here. Uh, yeah. See, this is my what laptop. Say this is my system where I'm accessing multiple applications. Say here in one tab I'm accessing mail, in another tab I'm accessing instant messaging, that is WhatsApp. Okay, and in another tab, say I'm using Amazon services. In another tab I'm surfing web, that is I'm googling something, and some other again I'm watching YouTube. Okay, so in this way, at a time, I'm using multiple applications at different tabs. Now the question is, when I receive a mail, the particular mail will be delivered to this particular tab itself, right? When I use if I'm supposed to receive a WhatsApp message, then that particular message will be delivered to the appropriate tab itself. Now, the question is how to differentiate this, how it is happening. It is because whatever the applications I'm using in my system, each application uses different protocols. See, if I'm using email, it uses a particular protocol. If I'm using WhatsApp, it uses another protocol which is designed to work on this WhatsApp. If I'm using Amazon services, then this uses a different protocol. Okay, so in that way, each protocol follows port addressing. Okay, say if email, it may uses a particular port address, say port 80. Okay, if WhatsApp, it uses different protocol, no, so it uses different port address. So looking at this port address, messages will be delivered to the respective tab. Okay, I hope this is clear to everyone. So different application uses different protocols. Okay, and these protocols uses different port addressing. Okay, so use with the help of port addressing, the messages will be delivered to the respective application. Okay, this is what happens when you serve or when you use multiple tabs in your system. Okay, that is all about service point addressing, where we discussed physical addressing, logical addressing, and port addressing. Okay, I hope I'm clear to everyone. Right? So let's move on to the protocols used at this layer, that is transport layer. The first protocol is transmission control protocol, second one is user datagram protocol, and third one is stream control transmission protocol. See this TCP, in short we call it as TCP, which is a connection oriented protocol, which means first it established the logical connection between transport layer at two hosts before transferring the data. So this protocol helps to establish a logical connection between, see, consider this is source and this is destination. Okay, TCP helps you to establish a logical connection between source and destination at the transport layer, at the transport layer. Okay, so next type of and this TCP provides flow control, error control, and congestion control. We already discussed all this in the network layer, right? So UDP, sorry, not network layer, in data link layer. So UDP is a connectionless protocol that transmits user datagram without first creating a logical connection. See, UDP stands for User Datagram Protocol, which is a connectionless. That means what? It will not establish logical connection between the host and the destination. Okay, but it transmits user datagram without creating a logical connection. And it does not, since there is no, this follows connectionless protocol, it doesn't provide flow control, error control, or congestion control. And the last type is SCTP, that is Stream Control Transmission Protocol. This responds to the new applications that are emerging in multimedia. See, nowadays we use Instagram, Facebook, and all, right? To cope up with that, this protocol is used at the transport layer. That is Stream Control Transmission Protocol. So, one second. So next we'll move on to the application layer protocol. So uh, So this application layer protocol, application layer, which enables the user to access the network. See, if consider I'm using WhatsApp. So this application works at the application layer where you are generating the data. So message will be created at the application layer. Okay, let's see what are all the services that we use at the application layer. Email services, like money transfer, that is bank transaction maybe, or you can say Google Pay, whatever, and the browsers and online shopping apps. So these are all the examples for application layer services. Okay, let's see what are there follows protocols to make user to use all these applications. The protocols used, if I'm surfing, I mean, if I'm using in WWB, that is, if you are accessing any Google or Yahoo, then it uses the protocol that is HTTP, Hypertext Transfer Protocol. Okay, the second protocol used here, if you are using email, then with respect to this protocol used is SMTP, that is Simple Mail Transfer Protocol. And third one, to transfer file from one host to another, then it uses FTP, that is File Transfer Protocol. If I'm accessing a site remotely, okay, then it uses terminal network or telnet and secure shell, that is SSH. And for that is uh, by the administrator to manage the internet at the global and local levels, then SNMP protocol will be used. That is Simple Network Management Protocol. And last one, DNS, that is Domain Name System, which is used by the to find the network layer address of a computer. DNS, Domain Name System. Okay, so these are the few protocols listed here which are used in the application layer: HTTP, SMTP, FTP, Telnet, SSH, SNMP, DNS. These are the few protocols listed here, and you can find few more as syllabus progress. Okay, so next, so that is all about application layer. And next topic is encapsulation and decapsulation. See, encapsulation is, see, when a message is created at the application layer, it is passed to the transport layer and then network layer and then data link layer and then passed to the physical layer, right? When data travels from one layer to another layer, certain information is added for the message or for the data, that we call it as encapsulation. Okay, so we'll see at each level what are the data that is added to the message. See, encapsulation is what? Adding header and the trailer to the data. Okay, and decapsulation is removing header and trailer from the data. Okay, so encapsulation happens at the sender side and decapsulation happens at the receiver side. Okay, so let's see this example. So consider this is a host and the destination. The source is sending data to the destination. As you know, since it is a host, it implements all the layers of the TCP/IP model, right? So at the application layer, message is created and it is passed to the next layer of the TCP/IP model, that is transport layer. Here, the header and the tailor will be added here. Okay, header will be added, which helps this header will helps to reassemble the data at the transport layer at the destination end. Okay, and once header is added at the transport layer, again the data will be transmitted to the next layer, that is network layer. Again at the network layer, the information will be added. Okay, so now what information is added here, that is also very important. Okay, so here at the network layer, the header contains address of the source and the destination. Okay, so source and the destination address will be added here, and then this complete message is again transferred to the next layer, that is data link layer. Okay, at the data link layer, it adds its own header. Okay, and this header will have the information that to which adjacent node the data has to be transferred, that will be mentioned at this layer. So this created message after adding head at the transport layer, it is called as segment. After adding data at the network layer, the message is called as or datagram, and then after adding header at the data link layer, it is called as frames. Okay, and at the physical layer, nothing will be added as such because the data will be in the form of bits, and this data is passed on to the router where three layers are implemented, and with respect to physical layer, nothing will be added, and it is passed to the data link layer where this again passed to the what network layer, and again it encapsulate all this data and again passed and delivered to the destination. At the destination end, each when it reaches data link layer, it removes the header of this layer, that we call it as decapsulation. Again, it is forward to the network layer and then it is forward to the transport layer, and again the final message will be transferred to the application layer. So this is what the encapsulation and decapsulation. Encapsulation is adding header to the message. Okay, and when it is delivered to the destination, decapsulation happens where it decapsulates the header at each level, and finally the message will be delivered to the destination host. Okay, so this is a simple example. The image that I have considered at the application, it is called as data or message. At the transport layer, header is added. So this we call it as segment. At the network, header is added. We call this as the datagram. And at the data link layer, again header is added, that we call it as frame. Okay, so this is another example. Addressing I already discussed, that is physical address or the MAC address. logical address, port address, and the specific address. See, if you look at this TCP/IP model, all five layers are there. Okay, at the application layer, the address is used as names. That is, say, where the data is created, right? So this, say, www.google.com. That is the name or the address followed here. Or you can say megashri.em@saividya.ac.in. That address is followed here. Okay, that address we call it as name. When it comes to transport layer, address used is port number. When it comes to network layer, address used is logical address. When it comes to data link layer, it follows link layer address. That is MAC address. Okay, these are the different addresses used at each layer. Okay, and the last topic of this chapter is OSI model, where you can see OSI model stands for open system interaction, open system interconnection, which is introduced in 1970 after designing TCP/IP model. As you can see here, there are 7 layers in OSI model. That is, two more added to this: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. See, these are the layers that comes under OSI model, whereas presentation and session layer is not present in the TCP/IP model. Here only we have physical, data link, network, transport, and application. So this is TCP/IP. This is OSI model. So whatever the functions that are implemented in presentation and session layer is merged in the application layer itself. Okay, so this is all about OSI model. And see, there is this OSI model is not a success model. There are three reasons. One is OSI was completed when TCP/IP was fully in place, and lot of time and money had been spent on the suit. So changing it would cost a lot. So TCP/IP was already in use, so replacing that would cost a lot. That's why OSI didn't model, it didn't become success. Second reason is some layers in OSI model were never fully defined. Okay, and the last reason is OSI was implemented by an organization in a different application, but it did not show a high enough level of performance to entice the Internet Authority to switch from TCP protocol suite to OSI model. So based on these are the reasons why OSI model didn't gain much success when it comes to TCP when it is compared with the TCP/IP model.